So the market's changing rapidly from a technology perspective, from a platform perspective, but from a fiber perspective as well.
Yeah.
And we're gonna dig into some of the new technologies, some of the not so new technologies, right? But I think one of the bigger impacts to the market is the process. And fiber and layer one infrastructure has typically been later in the construction schedule. It's been, I dare say, an afterthought, right? What fiber do we need to support everything else? And I think one of the biggest changes that we've seen is because of the scale and how fast the requirements are changing, it just needs to be addressed earlier on in the process.
Yeah. The AI data center, well, let's just start with AI in general.
Mm-hmm.
AI is going to make a profound change in our lives. It will be profound. It's that big of a thing. To the applications that are being developed for medicine, right? We've been doing genomics for how many years now, but AI is just going to make things that much faster. Medicine, education, right? Those are going to be profound differences. What's not profound is the way that we build data centers. Now, there's significant challenges that AI is creating just by the sheer number of GPUs, the power consumption of the GPUs, the connectivity of the GPUs. It is going to be a significant challenge, but it's not a profound change. For example, if we look at just the transport technology, okay, you look at InfiniBand, right? Or you look at RDMA over converged Ethernet, RoCE, right? InfiniBand has been around since the early 2000s. Ethernet been around since the 90s, even before that.
Yeah.
So that's not a new technology. High performance compute, right, has been done in scale for a number of years. So this is just building upon that high performance compute, building on whether you're doing InfiniBand or RoCE. But it did not have to be developed brand new from the ground up to support an AI data center.
Gotcha.
Right? Liquid cooling has been around since the 60s, where you could submerge network equipment into a liquid, right, and cool it. That's been around since the 60s. So yes, the challenge is there, but direct-to-chip cooling exists. So it's not like we have to create a whole new cooling technology to support AI data centers.
Gotcha.
Right? Power is a big, probably the biggest concern. And it's not so much for how do I deliver power to a specific server, right? It's how do I scale the power to the data center itself.
Right.
So what if we had a traditional elastic cloud data center, that's going to use somewhere between 8 and 12 kW per rack, right? Whereas in an AI data center, that rack is now going to be minimum 24 kW up to, we're hearing, 300 kW per cabinet.
Right.
So how do I get that much power delivered to that cabinet? Again, it's not a profound challenge. It's a significant hurdle, right? And the thing is, we're doing it. CoreWeave is building AI data centers. They have built AI data centers. They've solved the challenge of how can I run an AI data center. Now, the problem is we do not yet fully understand the AI workloads.
Right.
Right. So how much are we processing, right? How efficient is our switching?
Right.
Right. How efficient are our servers? Once we get a better understanding of the workloads, then we're going to be able to size our network properly, which impacts power, impacts cooling, impacts the whole data center infrastructure, and ultimately fiber as well. The fiber that we're using, it's traditional multi-mode single mode fiber that has been around for years, and we have been deploying it. So that's not even a significant hurdle. The challenge with the fiber is to get to the densities that we need.
Gotcha. Right.
So I think the way I look at it is we're building today AI data centers. The PUE, the power utilization of a data center, which we typically like to be as close to 1.0 as possible. Typically 1.06 is where we're hovering. The PUE may be 1.5, right? It may be 2. because we don't understand the workloads yet.
Right.
But ultimately, that's the real challenge is how can I get the PUE back to a level that's acceptable?
How to dial it in and,
Yes.
and maximize those efficiencies.
Absolutely.
Yeah. How does the requirements from a transport technology perspective affect the fiber infrastructure?
Yeah, that's a great question. So when we look at transport in an AI data center, and I know we keep saying AI data center, it's really machine learning data center is what we're talking about. There's two basic technologies for transport that you're going to use, one or the other. So, but the underlying technology is what's called RDMA, Remote Direct Memory Access. And what that means is that the GPU actually can talk to a GPU in another server or the same server without going through the CPU. The CPU would slow down because it's all processes.
Sure.
So being able to directly talk to one another, the GPU to the GPU, speeds up the process, and it's all in parallel as well. So multiple things happening all at the same time. But what that does, it means that each GPU has to be connected to all of the other GPUs. Okay, so that's RDMA. So that's just the technology of how they talk. So the transport technology behind it is either InfiniBand or RDMA over converged Ethernet or RoCE. Okay, so the real question is, how do those two differ that would impact my fiber infrastructure? Because as you already said, Jeff, we need to know this up front.
Right.
If we're planning this data center and we have to plan the fiber infrastructure along with everything else, we need to know what transport we're using so that we can size our fiber accordingly for connections. Okay.
So we talked about the transport technologies and, InfiniBand, RoCE. How does that impact our fiber infrastructure? Why is that important?
Yeah, it's a good question. So when you look at an AI data center network, InfiniBand and RoCE, from an InfiniBand perspective, all the GPUs are connected directly to one another through your InfiniBand switches. But unlike Ethernet, there's not a top of rack switch.
Okay.
So that means each GPU, whether it's 100 gig or 400 gig connection into the server for the GPUs in the server, each GPU has a connection back to the InfiniBand network, typically in a spine leaf pod. Okay, so which means if I have a rack of 72 GPUs, now I've got 72 8 fiber connections, right? That I have to connect each server to back to the spine leaf pod. So you can see now how the densities and how the number of fibers to support that rack, right? How it's increasing exponentially, right?
Right.
But not only that, I also have to have an Ethernet network that supports the storage and management of the switches. So now I have two front end and back end networks, as they're called, to support that InfiniBand AI rack. Okay, so that again scales that amount of fiber even more.
Gotcha.
Okay, so then it goes back to the spine leaf pod, and in spine leaf pod, it's funny because people talk about copper and they say copper is dead, right? Well, I think if you look at copper traditionally from a category cable, RJ45 connections, you'll see that is becoming much less important.
Sure.
However, if you look at a direct attached cable, which is a copper twin X cable, that's what's going to be in the spine leaf pod connecting all the leaf switches to the spine switches. So a tremendous amount of copper still, just with DAC cables. With Ethernet, it is more of a traditional Ethernet architecture and topology where you have top of rack switches, and now you're just feeding the top of rack switch back to the leaf switch. And it's less fiber, right? However, with that said, in a 3-tier closed network architecture, your size of your network and the number of GPUs supported differ between InfiniBand and RoCE.
Okay.
So RoCE can actually scale a little bit larger than InfiniBand.
Okay.
So I can have 24 1,000 GPUs in a single cluster with RoCE, whereas InfiniBand, I'm really limited to about 16,000, unless I add another layer of switching on InfiniBand.
Right.
So that's referred to as a switch radix, which is basically the total number of ports available in that single cluster.
Gotcha.
So there's advantages to both, right? InfiniBand, lower latency, low loss. I mean, it's there. For RoCE, using Ethernet as a base, you have to introduce a number of protocols, right, that allow that low latency, lossless transmission. So that's just a basic difference between the two. But from a fiber connectivity perspective, I think you'll see more fiber from an InfiniBand with an InfiniBand network. But to your point, you have to know that up front, and you have to do all the planning and network architecture decisions, transport decisions, which ultimately impact your fiber decisions.
Gotcha.